So if we have a function of u of x and y, and we can write down a function u of x and y plus iv of x and y, which is itself an analytic function, then we say that u is the harmonic conjugate of v, or vice versa, v is the harmonic conjugate of u. Or to say it both together, u and v are harmonic conjugates. And the interesting thing about harmonic conjugates is that if you look at the level curves of u, that is, if you draw a contour plot of u, so level curves are curves which have the same value of u in the xy plane, then those level curves will intersect the level curves of the function v at right angles. So to show this, we need to know the direction of the level curves. So basically, the trick for doing this is to remember that if you've got grad u, which in this case is the same as the vector du by dx, du by dy, then grad u points in a direction perpendicular to the level curves. Okay, it points in the direction of increasing u. So if we take, to show that the level curves of u and v are perpendicular, all we need to do is take the dot product of grad u with grad v, and that should be 0. So that gives us, that's going to give us du by dx times dv by dx plus du by dy times dv by dy. And then all we need are the Cauchy-Riemann conditions. So the Cauchy-Riemann, remember, are du by dx equals dv by dy, and du by dy equals minus dv by dx. So if we substitute those in, then we'll get, I'll change the v's into u. So the dv by dx is minus du by dy. dv by dy is du by dx. So we see this gives us 0. So they are indeed perpendicular. So yes, as long as they're perpendicular, as long as f dash is not 0, in which case these might end up being 0 anyway. But yes, as long as they've got length, and then as long as grad u and grad v have length, then they are indeed perpendicular.